Chapter 1, Section 1, Variables and Expressions. Our objective for this section is to translate between words and algebra, as well as evaluate algebraic expressions. Why we should learn this? Variables and expressions can be used to determine how many plastic drinking bottles must be recycled to make enough carpet for a house. Some vocabulary might be helpful to know. A variable is a letter or symbol used to represent a value that can change. Variables can be like x, y, or z. A constant is a value that does not change. This would be like 3, 5, or -2. A numerical expression only contains constants and operations, similar to something as 5 minus 1. An algebraic expression contains variables, constants, and operations. You might see something as such: 5x plus 3. When you evaluate something, you find its value. Some key words that you might find in word problems might help you to decide whether or not you should add, subtract, multiply, or divide. When you see things like plus, sum, increased by, or minus, difference, less than, you would either add or subtract. If you see words such as times, product, equal groups of, you should multiply. If you're dividing, you might find words like divide by or quotient. Let's practice. Translating from algebra to words. We're going to give two ways to write each algebraic expression in words. Let's look at this first one together. X plus 3. Well, the two examples we might see are the sum of x and 3. Or you might see x increased by 3. Take a minute to pause the video and attempt to solve B, C, and D. Now that you've had a chance to try B, C, and D, see if any of your results match up to the ones shown here. For B, we have m minus 7. You could also have the difference of m and 7, or 7 less than m. Notice here that it's not m less than 7. That would mean that you would have 7 minus m instead. For C, you might have two examples such as 2 times y, or the product of 2 and y. For D, you might have two examples such as k divided by 5, or the quotient of k and 5. Let's get a little bit more challenging. Translating from words to algebra. Eve reads 25 pages per hour. Write an expression for the number of pages she reads in H hours. Well, we see that it's 25 pages per hour. So that means every time 1 hour passes, she reads 25 pages. So, for every hour that goes by, she reads 25 pages per hour. Take a minute to pause the video and try B and C. Now that you have tried B and C, see if your results match the ones that we discover here. Sam is 2 years younger than Sue, who is Y years old. Write an expression for Sam's age. Well, since Sam is 2 years younger than Sue, we can have Sue represent the variable. Since Sam is 2 years younger, we're going to subtract 2 years from whatever Sue's age is. We do not know what Sue's age is, therefore a variable is replaced. Let's try C. William runs a mile in 12 minutes. Write an expression for the number of miles that William runs in m minutes. Well, m minutes divided by 12, because William runs a mile in 12 minutes. Let's try evaluating algebraic expressions. Evaluate each expression for x equals 8, y equals 5, and z equals 4. We're going to use substitution. We're going to substitute this variable for the numerical value that it stands for. Since x equals 8, if we look at a, we can replace x with an 8. Everything else in the equation, or the expression in this case, stays the same. So we continue to write a plus sign. We have y equals 5. So we can substitute the y in the expression here for 5. Since it wants us to evaluate each expression, we simply add 8 and 5, and we get a result of 13. Take a minute to pause the video and try B. Now that you've had a moment to try B, let's work on our substitution. X can be replaced with the 8 that we see above, so we have 8. A fraction is just a division problem, so we have 8 divided by, and z can be replaced with 4 as we see that that is given to us. Since we are evaluating this, we would simply do 8 divided by 4, giving us a result of 2. Let's try a recycling application. Approximately 14 20-ounce plastic bottles must be recycled to produce 1 square foot of carpet. Write an expression for the number of bottles needed to make c squares of carpet. Take a moment and pause the video and use some of the knowledge that you have just learned to try and solve or write an expression for A. Now that you've had a moment to try the first piece of this problem, let's see if you come to the right assumption. Write an expression. Well, we know that won't have an equal sign since it is an expression, and we know up here that approximately 14 of these 20-ounce plastic bottles must be recycled to produce 1 square foot of carpet. So, if we're trying to figure out how many are needed to make c square feet of carpet, your unknown becomes how many square feet you're using. So, 14 times however many square feet of carpet you're looking for. In B, it says find the number of bottles needed to make 40, 120, and 224 square feet of carpet. Take a moment and pause the video and try using your substitution to figure out how many bottles are needed for each of these square foot amounts. Now that you've had a chance to try and solve this, let's see what happens. We have 14 times, we're going to substitute our c value for 40 for our first one. And 14 times 40 is 560. We have our second one. We have 14 times the value 120. Well, 14 times 120 is 1,680. And last but not least, we have 14 times our 224 square feet, which gives us 3,136. That ends our lesson on variables and expressions.